We are going to start now the next lecture, lecture 5 of chapter 6, class 10th mathematics, triangles. So in this lecture, we will talk about the Pythagoras theorem and some problems based upon Pythagoras theorem. So earlier in this chapter, in the previous lectures, we have studied this result that if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, we are talking about a right angled triangle is given to us and a perpendicular is drawn from this vertex on the hypotenuse. This is right angle triangle and the perpendicular is drawn over here. Then the triangles on the both side of the perpendicular, we are talking about this triangle and this triangle. Both these triangles are similar to the whole triangle and to each other. We are saying these two triangles and this whole triangle, all these three triangles, these are similar to each other. Now we will use this result to prove the Pythagoras theorem. So Pythagoras theorem is that a right angled triangle is given to us and we have to prove that the square of the hypotenuse is equal to the sum of the square of the other two sides. And we are talking about a right angled triangle. We are saying this angle is 90 degree. The angle opposite to it, we are saying that is called the hypotenuse. This is the base and this is the perpendicular. This is the triangle. We are saying this is ABC. Now what we have to prove is that AB square plus AC square, that is that BC square, that is equal to AC square. This is the statement for the Pythagoras theorem and this thing what we have to prove. So to prove this, we have done the construction and we have drawn the perpendicular from this B on the side AC and the point where it intersects this point, it is point D, we are saying. Now we are saying that the triangle ADB and triangle ABC, these two triangles, these are similar triangles. How we have proved this? We are saying this angle is 90 degree and this angle at A, this is the common angle. So both these triangles, these are similar by AA axiom. So what we get from this is that AD over AB, that is equal to AB over AC. So this gives us that AD into AC is equal to AB square. Now if we are talking about the triangles BDC, we are talking about this triangle, and the triangle ABC, the larger one, we are saying both these triangles, these will be again similar because the angle at B is 90 degree, this angle at D is 90 degree and angle C is the common angle. So what we get from this is that DC over BC, that is equal to BC over AC. On adjusting these terms, we will get DC into AC, that is equal to BC square. Now if we add both these two equations, we will get AC is common from both these, we will get it is AD into DC is equal to AB square plus BC square. Look at this value AD plus DC. We are saying this AD plus DC means we are talking about AC. So this whole term will become AC square, that is equal to, we are saying it is AB square plus BC square. And this is what Pythagoras theorem is, that the square of the hypotenuse, that is equal to the sum of the square of the other two sides. Next is the converse of this theorem. So we are saying a triangle is given in which the square of one side is equal to the square of the other two sides. Then we have to prove that the angle opposite to the first side, it is the right angle. We have to prove that it is a right angled triangle. So we are saying in this triangle it is given that AB square plus BC square, that is equal to AC square. So we have this AC square, we are talking about it is this side. So we have to prove that the angle opposite to this is equal to 90 degrees. So we have done the construction over here and we have drawn another triangle DEF such that this length DE and AB, these two lengths are equal. We are saying EF and BC, these two lengths are equal, and this angle at E we are saying it is 90 degrees. This angle at E, it is 90 degrees. Now we have, how we have done the construction. We are saying we have drawn a line DE whose length is equal to AB. We have drawn from E, we have drawn an angle of 90 degree, and we have drawn a line at 90 degree angle, and the length of this side, it is BC. We have joined these two points D and F. We have joined these two points D and F, and we obtain this triangle. Now we are talking about the triangle DEF. This is DEF, and now in this triangle we are saying this angle is 90 degrees. So what is the length of this side? It is EF square plus ED square. We are saying the value of DF square, that will be equal to this. Now what is the value of EF? We are saying it is equal to BC, and ED, that is equal to AB square. So we are saying the length of this side, that is equal to, and this value is equal to AC square, because this thing is given to us, that the length of this AC, it is equal to this. So what we are saying, when we are drawing this triangle over here DEF, we have drawn it as right angle triangle. So because of Pythagoras theorem, we are saying we are having this, that DF square is equal to EF square plus ED square. This condition, AB square plus BC square is equal to AC square, this thing is coming from the fact that this is given to us, that the triangle, in the triangle ABC, the side AC, it satisfies this condition. So by combining these two results, what we get is that DF is equal to AC. That is, these two lengths, these are also equal. So in both these triangles, what we have is that the side AB is equal to ED, this side AC is equal to DF, and this side BC is equal to EF. So both these triangles, these sides, these are equal to each other. So we are saying both these triangles, these are congruent to each other. So we have proved that the triangle ABC is congruent to triangle DEF. And if these two triangles, these are congruent to each other, it means these two angles we are talking about, these are equal, and this is what we have to prove, that this angle is equal to 90 degrees. Next we have is, in a triangle ABC, AD is a perpendicular to BC. We are talking about this AD, it is perpendicular on BC. We have to prove that AB square plus CD square, that is equal to AC square plus BD square. So if we consider the triangle ABD, we have AB square is equal to AD square plus BD square. If we consider the triangle ADC, we have AC square, that is equal to AD square plus BC square. Now if we subtract these two equations, this AD square get cancelled, and what we are left with is AB square minus AC square, that is equal to BD square minus DC square. This is AB square plus DC square is equal to BD square plus AC square, and this is what we have to prove. You are saying this is the result that we have to prove. Next is, given a triangle ABC in which angle A is 90 degree, this angle at A, it is 90 degree, and AD, we are saying it is perpendicular on the side BC. We have to prove that AD square is equal to BD into CD. So in the triangle BAC, this larger triangle we are talking about, this angle at A is 90 degree, so this BC is the hypotenuse. So what we have is BC square that is equal to AB square plus AC square. Next, in the triangle ADB, we're talking about this triangle ADB, we are saying AB square is equal to AD square plus DB square. Next, we are talking about this third triangle over here. We have AC square that is equal to AD square plus DC square. Now, from the first two equations, we get is BC square that is equal to AD square plus DB square plus AC square. We have substituted the value of AB in this. From this equation, we are substituting the value of AC in this. So we will get BC square that is equal to AD square plus DB square plus, in place of AC square, we are writing it is AD square plus DC square. So this value is equal to 2 times AD square plus BD square plus CD square. This is the value of BC square. Now look at this length BC we have. This BC we can write it is equal to BD plus DC. We are saying this length BC we can write this, and that is equal to 2 times AD square plus BD square plus CD square. Now what is this value? This is BD square plus DC square plus 2 times BD into DC. Now this DC, BD, these two values get cancelled, and what we are left is AD square that is equal to BD into DC. Left with this result, and this is what we have to prove. Now in this next question, triangle ABC is given to us, and it is given that this AD, this is perpendicular on BC, such that AD square that is equal to BD into CD. We have to prove that ABC triangle, it is right angled at A. Now the triangle ADB we are talking about, this is right angled at D. So what we get is that AB square is equal to AD square plus BD square. Next we are talking about in the triangle ADC, we have AC square that is equal to AD square plus DC square. Now if we add both these equations, we will get it is AB square plus AC square that is equal to AD square 2 times BD square plus DC square. This AD square, this value we have, it is equal to 2 times it is BD into CD plus BD square plus CD square. This is equal to BD plus CD whole square. Now what is BD plus CD? This is BD length, this is CD length. So the total length we have, it is BC square. So we get it is AB square plus AC square is equal to BC square. So this means that Pythagoras theorem, this holds over here. We are saying the length of this BC that is equal to sum of these two sides. So what we have is that the angle opposite to this side, this will be of 90 degree, and this is what we have to prove. Now the next question we have is that in a triangle ABC, this angle at B, this is given to be acute angle. This angle is less than 90 degree, and this AD is the perpendicular on BC. We have to prove this result. This result is given over here. So it is AC square. We are talking about this side is AC square is equal to AB square plus BC square minus 2 times BC into BD. So we are talking about two right angled triangles. One is this, and second triangle we are talking about this. So for the first triangle, this triangle we are talking about, ABD, we have AB square that is equal to AD square plus BD square by Pythagoras theorem. For the second triangle, this ADC, we are saying we have AC square is equal to AD square plus DC square. Now if we add both these equations, or in place of this we are saying, in place of this DC square, we are writing this is AC square equal to AD square plus, we are saying this side we are getting it a DC. So in place of DC we can write it is BC minus BD whole square. So this is equal to AD square plus BC square plus BD square minus 2 times BC into BD. We are looking at this term AD square over here, this term BD square over here. The sum of these two values, it is AB square plus BC square minus 2 times BC into BD, and this is AC square equal to, and this is what we have to prove. Now BD is known as the projection of AB on BC. What this thing means is, if suppose we are saying we are having this BA is in this form, we are talking about this. Suppose this is some object and it is lying over here. This is the plane we are talking about, and it is lying like this. We have some source of light over here, and the light is falling on this object in this form. Then we will get the shadow of this object on this plane, and that shadow will be like this. We are talking about this line that I have shown in red color. This is the shadow of this object because of this source of light. This shadow of this object AB, this is called the projection. So in terms of projection, this theorem is stated as, in an acute angled triangle, acute angle means it is acute angled at B, the square of the side opposite to acute angle, that is AC square, this is AC square, is equal to the sum of the other two sides, AB square plus BC square, minus the product of one side and the projection of the first on the second. So projection means we are talking about this BD is basically the projection. Now in this next question, the difference between this question and the previous question is that over here the angle B is the obtuse angle. In the previous question, the angle B that was given to us, it was acute angle, now it is the obtuse angle. And the perpendicular that we have drawn from A, it is intersecting this BC produced at this point D. So if we consider the triangle ADB, we are having AB square is equal to AD square plus BD square. And if we are talking about the triangle, this whole triangle ADC we are saying, then we will have AC square is equal to AD square plus DC square. Now this whole DC, you can write it as AD square plus, in place of this DC we are writing it is DB plus BC whole square. So it is equal to AD square plus DB square plus BC square plus 2 times DB into BC. Look at this value over here, it is AD square plus BD square. We are talking about this term over here. So it means in place of this we can substitute this. So we get AC square is equal to AB square plus BC square plus 2 times DB into BC. And this is what we have to prove. Now in the previous case, we are saying this is the plane we have. In the previous case the object is lying in this form. In this case the object is lying in this form. The shadow of this object over here, it is like this, and shadow of this object over here, it is like these shadows means the source of light is over here. This is the source of light that we have, and this is the shadow being formed. Basically the light is falling on these objects in this way. The source of light is very far away. So these are called the projections. So this theorem can be stated in this form, that in an obtuse angled triangle means we are talking about this angle at B, it is obtuse angle. The square of the opposite side to the obtuse angle, it means we are talking about the side AC, is equal to the sum of the square of other two sides. Sum of the other two sides means we are talking about AB square plus BC square. Then next thing we have is plus the product of one side and the projection of the other on the first. These are the values we are talking about, and the projection over here, it is this BD is the projection. Now the next result we have is that in a triangle ABC, AD is the median. This AD we are saying it is the median. It means this BD length and this DC length, both these lengths are equal. We have to prove that AB square plus AC square is equal to 2 times AD square plus BD square. Now we are talking about this line AD. We are talking about this line AD. And we are talking about this triangle ABD. So if we are considering this triangle, then what we have is that this angle ADB, we are talking about this angle. This angle is an obtuse angle. So from the previous theorem, we have the result AB square, that is equal to AD square plus BD square plus 2 times BD into DL. Now in the second case, we are talking about the triangle ADC. This triangle we are talking about. This angle at A in this, it is an acute angle, and AL, it is the perpendicular in this case. So the result we have for this is AC square is equal to AD square plus CD square minus 2 times CD into DL. We have these two results from our previous two theorems. Now if we add both these results, if we add both these values, we will get AB square plus AC square, that is equal to 2 times AD square plus BD square. Why we are getting this value? Because in this case we are talking about this BD, that is equal to DC. This means this will become DC square. This BD is equal to, or you can write it as CD. So both these terms, DC square, then 2 times the CD into DL, 2 times CD into DL, these two terms, these gets cancelled out, and these terms we are talking about the BD square and BD square, we are getting it is BD square. So we are getting the final answer in the form that AB square plus AC square, that is equal to 2 times AD square plus BD square. So this result can be stated in the form that in any triangle, the sum of the square of any two sides, we are talking about sum of the square of any two sides means this AB square plus AC square, that is equal to twice the square of half of the third side together with twice the square of the median which bisects the third side. This we are talking about, that it is square half of the third side, and third side, half of the third side means we are talking about BD square, and square of the median which bisects the third side, it is AD square. This twice we are saying it is because of the 2 that is multiplied over there. Now in this next question, we are given sides of some triangles are given below, and we have to determine which of them are the right angled triangles. So first is 8, 15 and 17. We are saying this 17 is the largest value. So it means if it is right angle triangle, then it will be hypotenuse over here. So if we calculate the value of 8 square plus 15 square, we will get the answer is 289, and this value is equal to 17 square. So we are saying that these first dimensions we are talking about, dimension means we are saying this A is equal to 8, B is equal to 15 and C is equal to 17. These three values, they represent a right angle. They can be the length of sides of a right angle triangle. Second is 9 centimeter, 11 centimeter and 6 centimeter. 11 centimeter is the largest value. If it is a right angle triangle, then 11 will be the length of the hypotenuse. So we are calculating 9 square plus 6 square. The answer we are getting, it is 117, and this is not equal to 11 square. This value is not equal to 11 square. So it means we are saying that with these dimensions, that 9, 11 and 6, the triangle can never be a right angled triangle. Similarly, in the third case, we are talking about 2a minus 1, 2 root 2a, and the third is 2a plus 1 centimeters. Now in this case, suppose we are saying, we are considering these two, 2a minus 1 and 2 square root 2a as the two sides, and we square these values. So what we will get, it is 2a minus 1 square plus 2 root 2a square. The answer we will get, it is 4a square plus 1 minus 4a plus 4 into 2a. So this value comes out to be 4a square. These two values, this will become plus 4a plus 1. This is equal to 2a plus 1 whole square. And this is, what is the third value over here, 2a plus 1. And we are getting the answer is 2a plus 1 whole square. So we are saying that hence the given triangle is a right angle triangle, that it is possible that there will be a right angle triangle with these three values. Now an important thing to note over here is that how we are choosing these two values. To see how we are choosing these two values, you can substitute some value of a in this, and you can see which of these values it is the largest one. Suppose I am substituting a is equal to 1 in all these three values. I am substituting a is equal to 1. I will get p is equal to 1. I will get q is equal to 2 root 2. And I will get r is equal to 3. From these values, we can see that the largest of all these values is this 3. R is equal to 3 is the largest value, because the value of this term 2 root 2, it will be 2 point something, 2.8 almost. And from this we can say that this r is equal to 3 is the largest value. So what we are saying is we are using these two values over here to scale. That is the reason why we have chosen these two values, because this r is equal to 3 is corresponding to this value, and we are saying this will be the largest value. Next is, a man goes 15 meter due west and then 8 meter due north. So suppose the man started from the point A, he has moved 15 meter due west, and after that he has moved 8 meter to the north. How far is he from the starting point? So we are getting this triangle over here. So basically how far he is from the starting point, it is this distance, and this distance is 8 square plus 15 square and whole square root, and the answer we will get, it is square root of 289, that is equal to 17 meters. So we are saying that the man is 17 meter away from the starting position. Now next we have is, a ladder 25 meter long just reaches the top of a building. We are saying the length of the ladder we have, this is BC, and the length of height of the building that is given to us, it is 25 meter high from the ground. It is building over here, it means this angle is 90 degree. We are saying this is the building, and this we are talking about this is the ladder. Find the distance of the foot of the ladder from the building. We have to find this distance. This is the hypotenuse. This is the this 25 is the hypotenuse and this 24 is the perpendicular. So distance over here, this is 25 square minus 24 square. So the answer we will get, it is 625 minus 576, that is equal to 49. We are talking about square root of this, and this is equal to 7 meters. So we are saying the distance, or the distance of the foot of the ladder from the building is 7 meters. We are talking about this is the foot of the building and this is the foot of the ladder. So distance between these two is, it is 7 meters. Now next is, a ladder 15 meter long reaches a window which is 9 meter above the ground on one side of a street. So the length of the ladder that is given to us, it is 15 meter, and it reaches the window which is 9 meter high. We are talking about this point D over here. This is, we are saying this is the window. This is 9 meter above the ground. And keeping the foot of the ladder at the same point, this is the ladder we are talking about. We have kept the foot of the ladder at the point C. The ladder is turned on the other side of the street to reach a window 12 meter high. This is the window 2. Earlier the ladder was on this side, now the ladder has moved on this side. We are saying this point C, it is fixed over here. So we have to calculate the width of the street. This is A, B is the street. The ladder is kept at the point C. It is moving, it has reached the point D. When we have shifted to the other side, it has reached the point E. So we have two triangles over here. First we are talking about the triangle ACD. So in this triangle we can calculate the value of AC, that is square root of 15 square plus 9 square. We can calculate the value of this CB. This is equal to 15 square minus 12 square root. In the first formula also, it is not plus sign over here, it is minus sign over here. It is 15 square minus 9 square root. So the value of this length, this is the value of AC, we are saying this much length we are talking about. So this value on solving, you will get it is equal to square root of 144, that is equal to 12 meter. These calculations, these are shown over here. And this second length we are talking about, this CB length we are saying, this is CB, and this value is equal to, when we solve this value, you will get the answer is 81, square root of 81 meters, that is equal to 9 meters. So what we get is, this total length is AB, this is C, this much portion we are saying it is 12 meter, and this second portion we are saying it is 9 meter. So the total length of this AB we have, it is 9 plus 12, that is equal to 21 meters. Now next we have is two poles of height 6 meter. One is pole is of height 6 meter and second is of height 11 meters. If we draw the perpendicular from B to this, we are saying this height, this is 6 meter, this height, this will be 5 meter, because this total height it is 11 meters. If the distance between their feet is 12 meter, we are talking about this distance over here, this is 12 meter, find the distance between their tops. So looking at the figure over here, what we will have, this is 12 meter, this is 5 meter. So the distance between their top means we have to calculate the value of this BD. So length of this BD will be equal to 5 square plus 12 square and whole square root. So that is equal to square root of 169, that is equal to 13 meters. So we are saying that the distance between their tops, that will be 13 meter. Now next is, in a rhombus of side 10 centimeter, rhombus means a quadrilateral, all of whose sides their length they are equal. So we are saying this is a rhombus whose side length is 10 centimeter and one diagonal is 12 centimeter. This diagonal, say we are saying it is this length, we are saying this is 12 centimeter. Find the length of the second diagonal. Now from the properties of a rhombus, we know that the diagonals of the rhombus, they bisect each other and they are at a right angle, that is they are perpendicular bisector of each other. So what we get is, if we look at this AOB over here, we are saying this length AO and OC, these are equal. These length OD and OB, these are equal. And this angle over here, this will be 90 degrees angle. So what we get is that AO square plus OB square, that will be equal to AB square. Because if we look at this triangle over here, we are saying this is AOB. This angle is 90 degree. This is the side opposite to this angle, so this is the hypotenuse. So we are writing AB square, that is equal to sum of other two sides. Now AO square, we are saying this whole length is 12. So this AO will be 6 centimeter. So we are saying 6 square plus OB square, that is equal to AB is 10. This is given to us that AB is 10. So we get the value of OB is equal to square root of 10 square minus 6 square, that is equal to square root of 64, and this is equal to 8. So this is the length of OB, we are saying. This portion we are saying this is the length of OB. So the length of the second diagonal we are talking about, that is from this diagonal we are talking about DB, that will be 2 times of OB, that is equal to 16 centimeters. So we are saying that the length of the second diagonal is 16 centimeters. Now next is triangle ABD. It is a right angled triangle in which angle A is 90 degrees. We are saying this angle A over here, this is 90 degree. And AC, this AC we have drawn, this is perpendicular to the hypotenuse BD. We have to prove that AB square equal to BC into BD. So we know that the triangle ABC, this triangle we are talking about, this triangle ABC, this triangle, this is similar to the triangle DBA. This is similar to the triangle DBA. Why? Because this angle over here, for both these triangles, this is the common angle, it is 90 degrees. This angle is 90 degree. For the larger triangle, this angle is 90 degree. This is the common angle. So we are saying both these triangles, these are similar to each other. Similarly, this triangle ACD and ABC, these two triangles, these are similar to each other. And both these triangles, these smaller triangles, these are also similar to each other. Now from the first condition of similarity, what we have is AB over DB, that is equal to BC over BA. From the second condition of similarity, we have AC over DC, that is equal to BC over AC. And from the third condition of similarity, we have AD over CD, that is equal to BD over AD. So from all these three conditions, from this first one, we will get AB square. This is the first thing that we have to prove, that is AB square is equal to BC into BD. From the second one, we are getting AC square is equal to BC into DC. And from the third one, we are getting AD square is equal to BD into CD. So these are the three results that we have to prove. This is from the second one, it is first one, and this result we are getting, this is corresponding to the first result that we have to prove. Next is BL and CM are the medians of the triangle ABC. So we are saying these two lengths these are equal, these two lengths these are equal, and the triangle that is given to us, it is right angled at A. So it is given that this angle at A, it is right angle. So we have to prove that BL square plus CM square is equal to 5 times BC square. So we are talking about first the triangle. It is BAC, this larger triangle we are talking about. So in this triangle we have BC square that is equal to AB square plus AC square. Next we are talking about the triangle. It is BAL. We are talking about this triangle BAL. In this triangle also this angle A is 90 degree. So what we get is that BL square that is equal to AL square plus AB square. Now what is this AL? We are saying this AL, this is half of AC. So we get BL square that is equal to half of AC square plus AB square. This is BL square is equal to AC square by 4 plus AB square. So we get 4 times BL square that is equal to AC square plus 4 times AB square. Next we are talking about the triangle CAM. We are talking about this triangle CAM. And in this triangle we have CM square is equal to AM square plus AC square. Now in this triangle, this AM length, we are saying it is half of AB square plus AC square. On solving this, we will get 4 times CM square that is equal to AB square plus 4 times AC square. We are obtaining two relations. One is 4 times BL square. This is equal to AC square plus 4 times AB square. Second is 4 times CM square that is equal to AB square plus 4 times AC square. Now if we add both these equations, 4 is common. We are getting BL square plus CM square that is equal to, it is 4 times AB square plus AB square. It is 5 times AB square plus it is AC square plus 4 times AC square. It is 5 times AC square. Now we have this first equation with us, that BC square is equal to AB square plus AC square, and this whole value is equal to this BC square. We are saying this whole value will be equal to 5 times BC square using this first equation. And this is what we have to prove, that 4 times BL square plus CM square is equal to 5 times BC square. Next is, in the given figure, the perpendicular from A on the side BC, this is the perpendicular from A on the side BC of a triangle ABC, it intersects this BC at the point D, such that this BD, this is equal to 3 times this length CD. We have to prove that 2 times AB square is equal to 2 times AC square plus BC square. Now we have two right angled triangles over here. One is the triangle ABD. So for this triangle we have AB square is equal to AD square plus BD square. Second right angle triangle we have this, and in this triangle we have AC square is equal to AD square plus DC square. Now if we subtract these two equations, this AD square gets cancelled, and what we are left with is that AB square minus AC square that is equal to BD square minus BC square. Now this value we are talking about, this BD value, it is given to be that this BD is 3 times CD. So it is 3 times CD square minus CD square. In place of BD we are writing this is CD over here. So we get it is equal to 8 times CD square. Now what we are saying is that this length BC we are talking about, this is the point D over here. Suppose this length is, we are saying X, that is CD length is X. This length we are saying this is 3X. So total length we are saying it is 4X. So it means when we are talking about CD is equal to X multiplied and divided with 4, you get this 4X means we are talking about BC over 4. So we have CD is equal to BC over 4 square, and this is equal to 1 by 2 into BC square. So the result now we have is that AB square minus AC square, that is equal to 1 by 2 times BC square. This is AB square minus AC square, that is equal to 1 by 2 times BC square. Now if we multiply this equation with 2, we will get it is 2 times AB square, that is equal to 2 times AC square plus BC square. And this is what we have to prove, that 2 times AB square plus 2 times AC square is equal plus BC square. This is the result that we have to prove. Now next is, in a triangle ABC, angle B is 90 degrees. This angle we are saying this is 90 degrees, and D is the midpoint of BC. We are saying both these lengths, these are equal. We have to prove that AC square, I'm talking about this AC square, that is equal to AD square plus 3 times CD square. So when we are talking about this triangle, right angle triangle ABC, we will have AC square, that is equal to AB square plus BC square. When we are talking about the triangle ABD, the result we have is corresponding to this, it is AD square equal to AB square plus BD square. So if we calculate the value of this AB square and substitute it over here, or we are saying we are subtracting these two equations, what we get is that AC square minus AD square is equal to BC square minus BD square. The answer we require, it is in the form of 3CD square. We are saying we are getting AC square over here, AD square over here. The answers we require, it is in the form of CD. We are talking about this length. This is the length BDC. This BD length and DC length, these are equal. So it means in place of BD I can write it as DC square, and in place of BC I can write it as 2 times DC square. So it is 4 times DC square minus DC square. On solving this you will get it is 3 times DC square. So the final answer that we will get it is A square is equal to AD square plus 3 times CD square, and this is what we have to prove, that AC square equal to AD square plus 3 times CD square. This is the final answer that we will get. Now the next is, a triangle ABC is right angled at B. We are saying this is right angled at B and D is the midpoint of the side BC. We have to prove that AC square equal to 4 times AD square minus 3 times AB square. So in this triangle ABC, we have AC square, that is equal to AB square plus BC square. We are saying this is equal to AB square. In place of BC, we can write it as 2 times BD square, that is equal to AB square plus 4 times BD square. Now in this triangle, from this triangle we are saying what is the length of this BD. BD square will be equal to AD square minus AB square. We are substituting this value in this equation and we will get it is AB square plus 4 times AD square minus AB square. So the answer we are left with is 4 times AD square minus 3 times AB square. So what we get is that AC square, that is equal to 4 times AD square minus 3 times AB square, and this is what we have to prove. Now next question we have is, in an isosceles triangle ABC where AB is equal to AC and BD is perpendicular to AC, prove that BD square minus CD square equal to 2 times CD into AD. So from the triangle ABD, this triangle we are talking about, we have this angle over here, this is 90 degrees. So AB square, that is equal to AD square plus BD square. The sides that are equal, they are AC and AB, these two sides, these are equal to each other. And by using the fact that this AB and AC, these are equal, we get that AC square, that is equal to, we are saying both these sides, these are equal to each other. So in place of AB we are writing it as AC, so it is AC square plus AD square is equal to BD square. Now when we look at this AC, it is AD plus DC. We are talking about this term AC, the value is AD plus DC, and this is equal to AD square plus BD square. Now if we open this whole square, we will get it is AD square plus CD square plus 2 times CD into AD, that is equal to AD square plus BD square. This AD square gets cancelled, and the result we are left with is that BD square minus CD square is equal to 2 times CD into AD. We are talking about this result over here, and this is what we have to prove. Now in this next question, it is triangle ABC. So it is isosceles triangle, right angled at C. This angle at C, it is 90 degree. Isosceles triangle means these two sides, these are equal, because hypotenuse is the largest side. Hypotenuse cannot be equal to any other side. So we have to prove that AB square is equal to 2 times AC square. So by Pythagoras theorem we have AC square plus BC square, that is equal to AB square. So what we get is AB square is equal to 2 times AC square, because both these sides AC and BC, both these sides, these are equal. It is given in the question that it is an isosceles triangle. So when we are saying it is isosceles triangle, this is the hypotenuse, and hypotenuse is the triangle that is the largest side, that is the other side, they are less than the length of the hypotenuse. So we are saying these two sides, these two must be equal in length. Next is triangle ABC is an isosceles triangle with AC is equal to BC. This AC and BC, these are equal to each other. If AB square is equal to 2 times AC square, we have to prove that triangle ABC is a right triangle. So to prove this, we are saying we can write it as AB square, that is equal to AC square plus AC square. In place of this AC, we are saying we can write it as BC. So we are writing it as AC square plus BC square. and this thing gives us, this is the result for, this is the Pythagoras theorem we are saying. So by the converse of Pythagoras theorem, what we get is that AB square, that is equal to AC square plus BC square. It means this angle at C, it is 90 degrees. It means triangle ABC is a right angled triangle. Now next we have a triangle ABC. It is right angled at C. So this angle at C, it is given to be 90 degrees. And CD, this we are talking about, this is at angle at D is also 90 degree. Now the length of the side opposite, this is the vertex A. So length of this side is given to be A. This is vertex B. So length of this side it is B. This is vertex C. So length of this side AB, it is small c. Further, it is given that the length of this CD, it is P. We have to prove that CP is equal to AB. So if we talk about the area of the triangle ABC, why we are talking about the area, we have to prove that this is C into P, that is equal to A into B. So if we look at these two values A and B, these are connected by the formula half, this is base into height. This is basically the value of the area of the triangle ABC. And if we are taking this AB as the base and this is the perpendicular, then the area of this triangle is half, base is C and height is P. So this half gets cancelled and what we get is AB is equal to CP, and this is the first part that we have. Now next thing we have to prove is that 1 by P square, that is equal to 1 by A square plus 1 by B square. So we get 1 by P, that is equal to C over AB. Now we want the value as this, the term we are proving it is 1 by P square. So we are squaring both sides. We are squaring both sides and we will get 1 by P square, that is equal to C square over A square B square. Now what is this C square equal to? This is the hypotenuse for this triangle. I am talking about this value. What we have is 1 by P square, that is equal to C square over A square into B square, and we are saying this C square, this is equal to A square plus B square. So this gives us 1 by P square is equal to 1 by B square plus 1 by A square. What we have done, we have separated this denominator with A square and with B square. So when we separate these terms, we will get A square over A square plus B square plus B square over A square into B square. And this is not plus sign over here, this is multiply sign over here. So we will get these values. So this A square and A square get cancelled, B square and B square can cancel, and the answer we are getting, it is 1 over P square is equal to 1 over B square plus 1 over A square. Next is, in an equilateral triangle, prove that 3 times the sum of the square of one side is equal to 4 times the square of one of its altitude. So suppose we are saying a triangle ABC is given, which is an equilateral triangle. This is ABC. This is an equilateral triangle, means all these sides, these are equal, all the angle they will measure 60 degree. And we have, next thing that is given to us is we have to draw an altitude. Suppose we have drawn this altitude from A to this, and we are saying this AD is the altitude over BC. So what we have to prove is that 3 times the square of one side, that is 3 times the square of one side, you can take any one of these sides, that is equal to 4 times the square of one of its altitude. It is 4 times AD square. This thing we have to prove. Now if we talk about the two triangles, one is this triangle ADB and second is the triangle ADC. We are saying this angle at B over here and angle at C over here, these two angles, these measure 60 degree. These angle, these are of 90 degree measure. Then it is given that this side AB and AC, these are equal in length. So what is we get is that the triangle ABD, this is congruent to the triangle ACD. Now if these two triangles, these are congruent to each other, it means the sides BD and DC, these are equal. We are saying this BD and DC, both these values, these are equal to each other. So in the triangle ADB, we are talking about this triangle ADB, we have, from this triangle we are talking about, the result we have is AB square is equal to AD square plus BD square. Now the value of this BD we have, it is AD square plus 1 by 2 times BC square. In place of BD we are writing 1 by 2 times BC square. So we get that AB square, that is equal to AD square plus 1 by 4 times BC square. Now in this BC we are saying this whole length BC and this length AB, both these lengths, these are equal. So we are saying it is equal to AD square plus 1 by 4 times AB square. So this gives us that 3 by 4 times AB square, that is equal to AD square, and this gives us that 3 times AB square, that is equal to 4 times AD square. And this is what we have to prove, that 3 times AB square, that is equal to 4 times AD square. Now next we have is, in an equilateral triangle with side A, prove that altitude is equal to root 3 by 2A and area is root 3 by 4A square. So we are saying, suppose ABC, this is an equilateral triangle. This triangle we are talking about. So all the sides of this triangle, they are of length A units. We are saying this side is also of length A units. Then we have drawn AD. This AD we have drawn. This is perpendicular on BC. Now in triangle ADB, we are talking about this triangle ADB and the triangle ADC. If we look at these two triangles, this angle over here, this is 60 degree. This angle over here, this is 60 degree. These two angles, these are of 90 degree measure. And the sides, this side A, this side is A. So it means both these triangles, this side it is common. So both these triangles, we are talking about ABD and the triangle ADC, both these triangles, these are congruent to each other. And if these triangles, these are congruent to each other, so what we get is that this length BD and this length DC, we are talking about these two lengths. One is this length BD and second we are talking about this length DC. Both these lengths, these are equal, and the value of these lengths will be A by 2 and A by 2. Now we are talking about this altitude. We have to calculate the value of the length of this altitude. So length of this altitude will be square root of, this is the hypotenuse for the triangle, it is A square, minus the base for this triangle. We are saying ABD, we are considering the base of this triangle, it is A by 2 square. On solving this, you will get it is square root of A square minus A square by 4, that is equal to square root of 3A square by 4, that is equal to root 3 by 2A. So we are saying the length of this altitude we are talking about, it is root 3 by 2A. Now when we have to calculate the area of this triangle, we are saying the base of this, the length of the base we have, it is A, the height we have, it is root 3 by 2A. So the area of this triangle will be 1 by 2 into base into height, and this value is equal to root 3 by 4 a square. So we are saying the area of triangle ABC, that is equal to root 3 by 4 a square. Now in this next question, O is the point in the interior of a triangle ABC. So we are saying this O is any point in the interior of the triangle, and we have drawn the perpendiculars OD, OE and OF on these three sides of this triangle. Then we are joining all these points OA, OB and OC. Now we have to prove that this OA square plus OB square plus OC square, this is the first thing that we have to prove, that these all terms, these are equal to AF square plus BD square plus CE square. So if we look at the figure, what we are saying is that this OA square plus OB square plus OC square, we are talking about these three sides. With the minus sign we have OD square, then OE square and then OF square. These three sides, these are with the minus sign. Then the next three terms we have, it is AF square, next it is BD square and next it is CE square. So if I write for this triangle using the Pythagoras theorem, what we have is OA square, that is equal to AF square plus FO square. Then we are writing for this triangle, we have this angle is 90 degree, so we have OC square, that is equal to OE square plus EC square. Then we come to this triangle, this angle is 90 degree, so what we get is that OB square is equal to OD square plus BD square. So this equation we are talking about, from this equation we can write AF square, that is equal to OA square minus OF square. From this equation we can write the value of CE square, that is equal to OC square minus OE square, and from this equation we can write the value of BD square, that is equal to OB square minus OD square. Now if we add these three equations, we are talking about these three equations, this is equation 1, this is equation 2 and this is equation 3. Now if we add these three equations, we will get the first result. These are the values we are talking about: AF square, then it is BD square, and then it is CE square, and rest all the terms when you will add, you will get this first answer. Now in the second case, what we have to prove is that this AF square plus BD square plus CE square, that is equal to AE square plus BF square and CD square. Now to prove this part, we are considering the triangles ODB, then ODC. We are talking about these two triangles, and we are saying for these two triangles, when we write the terms using Pythagoras theorem, what we get is that OB square, that is equal to OD square plus BD square. Similarly, for this triangle, when we will write these terms, it is OC square is equal to OD square plus CD square. These values, these are mentioned over here. That's corresponding to the triangle ODE, we have this term. Corresponding to the triangle ODC, we will get this expression. Now if we subtract both these expressions, we will get OB square minus OC. We are talking about, we are subtracting these two expressions, and we will get this answer from subtracting these two expressions. Similarly, we are saying that OC square minus OA square, that is equal to CE square minus AE square, and OA square minus OB square, that is equal to AF square minus BF square. We are saying in the first case we are considering these two triangles. I am marking it in the figure. And in the second case we are considering these two triangles, and in the third case we are considering these two triangles. We are talking about the triangle AFO, OFB. Then we are considering AOE and EOC. So when we consider these three triangles, we are saying from the first one we are getting this, from the second we are getting this relation, and from the third we are getting this relation. Now if we add all these values, we will get the required answer. We are talking about these three equations. When we add these three equations, we will get the answer in this form. We will get the answer in this form, and from this we will get this expression, that is expression number 2 that we need to prove. Now in this next question we are given that O is any point inside a rectangle ABCD. So this is the point O we are saying. We have to prove that OB square, we are talking about this length OB square plus OD square, that is equal to OA square plus OC square. Then we have to do the deduction that in the given figure O is any point inside the rectangle such that OB is 8, OD is, these values these are given to us. This length is 8 centimeter, 5 centimeter, 6 centimeter, and x centimeter. We have to find the value of this x. So to prove this result, first of all we have to prove this result, that OB square plus OD square is equal to OA square plus OC square. To prove this result, we have drawn a line. This line we are talking about PQ, we are saying we have drawn this line and it is parallel to BC. Both these lines, these are parallel to each other, and it passes through the point. We are talking about this line PQ, it passes through the point O, and this line PQ is parallel to BC. Now we are talking about the angle at the point C over here. It is 90 degree because it is a rectangle. So this angle Q is 90 degree. This angle B is 90 degree. So this angle P is 90 degree. So what we get it that this line PQ is perpendicular to AB as well as it is perpendicular to DC. So both these angles we are saying these are equal to 90 degree. So what we get from this is that this PQPA and this second figure QCBP, both these are rectangles, because these angles we are saying over here, these angles these are 90 degrees. Opposite angles are, all the angles of these figure these are 90 degrees, so these are rectangles. So from this what we get is that the opposite sides they are equal to each other, that is this length BP and this length QC, these are equal to each other, and this length AP, this length DQ, these are equal to each other. Then all these lengths BC, QP and DA, all these lengths these are also equal to each other. Now if we consider the triangle OPB, we are talking about the triangle, I'm marking it over here, it is OPB triangle we are talking about. It is right angled at P. So what we get for this is that OB square, that is equal to OP square plus PB square. Next we are considering the triangle OQD. We are talking about this triangle OQD. So for this triangle we are saying OD square, that is equal to OQ square plus QD square. Third we are considering the triangle OPA. For this triangle we are saying OA square, that is equal to OP square plus AP square. And last we are considering the triangle OQC. For this triangle we have OC square, that is equal to OQ square plus QC square. Now if we add first two equations, we are adding these two equations, and we will get OB square plus OD square, that is equal to OP square plus OQ square plus PB square plus DQ square. Now look at these values over here. This is PB and DQ we are talking about, and what we have seen that this PB is equal to QC. So in place of PB we can write it as QC square, and in place of DQ we are talking about this length DQ, we are saying that is equal to AP. So we are writing it as AP square. Now look at these values over here. We are talking about OP square plus AP square. Look at this third equation over here. OP square plus AP square. The value of this term we have, in place of these two values we are saying we can write it as OA square. Similarly, we are saying OQ square plus QC square. We are talking about these two values. So what we get is, in place of these two values we can write it as OC square. So the result we reach is that OB square plus OD square, that is equal to OA square plus OC square, and this is what we have to prove. Now we are left with the deduction part and the calculation. These are shown on our next slide. So we are saying we have to calculate the value of OC, that is equal to X, and the formula now we have it is OB square plus OD square, that is equal to OA square plus OC square. So if we substitute all these values in this formula, we will get these values over here, that 6 square plus 8 square is equal to 5 square plus x square, and on solving this we will get the value of x square is 75. So x is 75, square root of 75, that is 5 root 3, and on solving this you will get the value of OC is 8.66 centimeter. The next question we have is, prove that the sum of the squares on the sides of a rhombus. So we are talking about this AB square plus BC square plus CD square plus DA square, that is equal to sum of the squares on its diagonal. We are talking about it is sum of these squares. Now we know that the diagonals of a rhombus, they are perpendicular bisectors of each other. That is, this OA and OC, these lengths are equal. OB and OD, these lengths are equal, and these angles over here, these are of 90 degree measure. So if we consider this triangle OAB, we get that AB square, that is equal to OB square plus OA square. Now if we are talking about this OB length, it is half of the length DB, and this OA is half, this OA is the length half of the length AC. So what we get is that 4 times AB square, that is equal to BD square plus AC square. Similarly, if we will consider this second triangle, we will get 4 times BC square is equal to sum of the squares of diagonals. Next, if we consider this triangle DOC, we will get 4 times DC square, that is equal to sum of the squares of diagonals. And last we have, if we consider this triangle over here, we will get 4 times AD square, that is equal to sum of these values. So if we add these all equations, what we will get is, when we add all these values, the 4, it is common, and it is AB square plus BC square plus CD square plus DA square, that is equal to, and these values we are saying these are also 4 times, so it is 4 times of AC square plus BD square, and what we get from this is these two 4 gets cancelled, and the final answer we will get it is AB square plus BC square plus CD square plus DA square, that is equal to AC square plus BD square. Next we have is P and Q. These are the points on the side. We are talking about these are the 2 points P and Q. These are the points on the sides ABC of the right angle triangle C. And we have to prove that AQ square, this is the length AQ square plus BP square, that is equal to AB square plus PQ square. So it is given that the triangle ABC, it is right angle, it means this angle over here it is 90 degrees. So first of all we are considering the triangle ACQ. Now in this triangle we have, for this triangle we are saying AQ square, that is equal to AC square plus CQ square. Now second triangle we are considering, it is triangle BCP. This triangle we are talking about. In this triangle we have BP square, that is equal to BC square plus PC square. Third triangle we are saying it is ACB, this larger triangle we are talking about. For this triangle we have AB square, that is equal to AC square plus BC square. And last triangle we are talking about, it is triangle CPQ. For this triangle we are saying we have PQ square, that is equal to CQ square plus CP square. Now from this result, AQ square is equal to AC square plus CQ square, and BP square is equal to BC square plus PC square. From these two results we get that AQ square plus BP square, that is equal to AC square plus BC square plus CQ square plus CP square. This value we are saying this is equal to PQ square, and this value AC square plus BC square, this is equal to AB square. So combining these all results we will get the required result, that AQ square plus BP square, that is equal to AB square plus PQ square. These values we are talking about, we have substituted these values over here, and this PQ square in place of CQ square plus CP square, and we obtain this final answer. Now in this question we have this figure is given to us, and we are given that PQR, this is a right angle triangle. This angle over here, this is given to be 90 degrees, and it is right angled at this point Q, and the point S and T, they trisect the side Q and R. They trisect means the length of this it is X, then length of this it is X, length of this portion is also X. That is all these 3 points, they are equidistant from each other. Now we have to prove that 8 times PT square, I'm talking about what is PT, it is PT square, that is equal to 3 times PR square plus 5 times PS square. So we are talking about the right angled triangles over here. So if we consider first the right angled triangle, it is PQS. So for this triangle we have PS square is equal to PQ square plus QS square. Second, we are considering the triangle PQT. For this triangle we are saying PT square, that is equal to PQ square plus QT square. The third triangle, we are talking about this triangle over here, and this triangle is PR square, that is equal to PQ square plus QR square. So these are the three values that we have obtained. This is PT square, then we have PS square, and then we have PR square. Now if we substitute these values in this equation, we are verifying whether these are satisfying these conditions or not. So what we get is that 8 times PT square means PQ square plus QT square. We are saying this should be equal to 3 times PR square is PQ square plus QR square plus 5 times PS square means PQ square plus QS square. Now when we open these brackets, what we will get it is 3 times PQ square plus 5 times PQ square plus 3 times QR square plus 5 times QS square. This is 8 times PQ square plus 8 times QT square. So 8 times PQ square, this gets cancelled from both the sides. Now the lengths we are talking about, all these lengths we have considered, their value is x. So we substitute these values over here. So in place of QT, this length we are talking about, we will get it is 8 into 2x square. And we are saying in place of PQ, we are writing it is 5 times PQ square plus 3 times it is QR square. Now the value of this QR, it is 3x square plus 5 times QS square. And this PQ square is already cancelled over there, this term we are saying, and we are left with this QS square. QS square is x square. So when we talk about, when we calculate this value, it is 8 into 4x square, and that value comes out to be 32x square. When we calculate this value, it is 27x square plus 5x square, that is equal to 32x square. So what we get is that the left hand side value is 32x square, right hand side value is 32x square. So what we get from this is that this equation, the given equation, is satisfied. So this proves that this equation is true, and this is what we have to prove. Now next is in an isosceles triangle ABC. So this triangle is given to be isosceles. We have this side AB and AC. These two sides are equal to each other, and D is a point on BC. D is any point on BC. We have to prove that AB square minus AD square, that is equal to BD into CD. So to prove this, we have done the construction over here, and we have joined these points A, and we have drawn this perpendicular AL on BC. We have constructed this perpendicular AL on this line BC. So we are considering now the triangles ALB. We are talking about this triangle ALB. So in this triangle, we are saying AB is the hypotenuse, and it is equal to the hypotenuse of the right angle triangle ALC. We are talking about these two triangles. So these two hypotenuse, we are saying hypotenuse of both these triangles, these are equal to each other, and AL, we are saying it is the common side over here. So what we get is that both these triangles, that is BLA and the triangle ALC, both these triangles, these are congruent to each other. So if these two triangles, these are congruent to each other, so what we get is that this BL and CL, we are talking about this length BL and this length CL, these are equal to each other. Now we have another triangle over here. We are talking about this right angle triangle ADL. So in the triangle ALB, we're talking about this triangle, by Pythagoras theorem, we have AB square that is equal to AL square plus BL square. In this triangle we are saying, that is ALD, we have AD square that is equal to AL square plus DL square. Now if we subtract both these equations, we get AB square minus AD square that is equal to BL square minus DL square, and this value is equal to BL minus DL into BL plus DL. Now look at this value over here. We are talking about this straight line. It is B, D, L and C. These points we are talking about. So BL we are saying it is this length, and DL we are saying it is this length. So when we are subtracting these two values, the answer we are getting it is BD. Next we are talking about the length BL. This is the length BL plus DL we are talking about. Now what we have proved in over here is that this length BL and LC, these are equal to each other. So we are saying this length BL and this length LC, these two lengths are equal to each other. So what is the sum of these two lengths? That is DL. In place of BL we are writing in this, it is LC. So this whole length will be D into C. So what we get is that AB square, we are talking about this term over here, minus AD square, that is equal to this value, that is BD into CD. So this is what we have to prove, that AB square is equal to AB square minus AD square is equal to BD into C. Next we have is in an equilateral triangle ABC. So this EBC is given to be an equilateral triangle. So equilateral triangle means that all the sides of this triangle, they are equal in length. The point D is on the side BC. We are saying any point D is there which is on the side BC. We have such that BD, this length we are talking about BD, that is 1/3 of this length BC. So if this length is x, this length is 3x and this length will be 2x. We have to prove that 9 times AD square, that is equal to 7 times AB square. So to prove this, we have drawn a perpendicular over here, AL we are saying. Now in the right angle triangle ALB we are considering. We're talking about this right angle triangle ALB. And second right angle triangle we are talking about, it is ALC. These are the two right angle triangles we are talking about. We are saying it is an equilateral triangle. It means this side AC and AB, these are equal. This AL is the common side. This angle is 90 degrees angles for both these triangles. So both these triangles, these are congruent to each other. So what we get is that this point L over here, this is the midpoint. That this length BL and LC, both these lengths, these are equal to each other. Now in the triangle ALB, we are talking about the triangle ALB. What we have is AB square, that is equal to AL square plus BL square. Next we are talking about the triangle ALD. We are saying this triangle we are talking about ALD. In this triangle, what we get is AD square, that is equal to AL square plus DL square. Now what we have to calculate is, we have to calculate the value in over here, that is 9ad square is equal to 7ab square. So we are starting solving these values over here. We are saying ad square, that is equal to al square plus dl square. In place of dl, we can write it is al square plus, we are saying, bl minus bd whole square. When we open these brackets, we will get it is al square plus bl square plus bd square minus 2 times bl into bd. Now if we look at this value, al square plus bl square, it is this value we have already proved, this is equal to ab square. We are talking about this result over here. We are using this result to calculate the value of this term. And the next term we have it is plus bd. When we are talking about, we are saying this is 1 by 3 of bc, and it is square over here. Next term we are talking about, it is, we have calculated this term bd, and next term we are saying it is minus 2 times, it is bl. Now the value of bl, it is bc by 2 into bd, it is bc by 3. So when we solve all these values, we are further having this AB is also equal to BC, because this triangle we are talking about, it is an equilateral triangle. So what we get is that on solving all these terms, we will get this value over here. From the first term we are getting it is BC square. From the second term we are saying it is 1 by 9 BC square. From the third term we are saying these two gets cancelled, and what we are left with is, it is BC square by 3, that is 1 by 3 BC square. So on solving these values, you will get the final answer is 7 by 9 BC square. So what we get is that A final answer we get after solving this, it is AD square, that is equal to 7 by 9 AB square, and this result gives us the final answer as 9 times AD square is equal to 7 times AB square. Next is, in a quadrilateral ABCD, angle B is given to be 90 degree. AD square, we are talking about this side, AD square plus AB equal to AB square plus BC square plus CD square, this is given to us. We have to prove that the angle ACD, we are talking about this angle, we are saying this angle is 90 degrees. So to prove this, we are saying in the triangle ABC, we are talking about this triangle ABC, the value of AC square, that is equal to AB square plus BC square. Now it is given to us that AD square is equal to AB square plus BC square plus CD square. It means we are talking about this value AB square plus BC square over here. This is AB square plus BC square over here. So in place of this term, we can write this is equal to AC square plus CD square. So what we get is that AD square, we are talking about this term AD square, that is equal to AC square plus CD square. It means this triangle, we are saying this is a right angle triangle. This is right angle over here, and this is what we have to prove, that this angle ACD is of 90 degrees. So this proof, we are saying this step of proof, it is by the converse of Pythagoras Next is equilateral triangles are drawn on the side of a right triangle. We are saying this right triangle ABC is given to us, and equilateral triangle means this is an equilateral triangle, this is an equilateral triangle. So equilateral triangle means this AB, AF and FB, these lengths these are equal. AC, AE and EC, these lengths are equal. Then BC, BD and CD, these three lengths these are equal to each other. We have to prove that the area of the triangle on the hypotenuse, we are talking about this triangle, is equal to the sum of the areas of the triangles on the other two sides. So if we look at these three triangles over here, we are talking about this triangle, this is the second triangle and this is the third triangle we are talking about. All these three triangles, these are equilateral triangle. So it means their angles are of measure 60 degree. It means all these three triangles, these are similar to each other. Now as these triangles, these are similar to each other, so we are talking about the area of triangle BCD over area of triangle CAE plus area of triangle ABF over area of triangle CAE, that is equal to, when we are talking about the area of the triangle BCD and CAE, we are talking about these two triangles. So what we get is the value is BC square over CA square. This result we have already studied, that the areas ratio of the areas of two similar triangles is equal to square of one of their sides. So length, all these triangles, these are equilateral triangles, so the side we are considering it is, for this triangle we are considering it is BC, and for this triangle we are considering it is AC. Similarly, for the next two triangles we are talking about, the answer we get it is AB square over CA square. Now when we take the LCM over here, we are saying that this is the numerator part and this is the denominator part, and on solving these values over here, it is AC square in the denominator, we will get it is BC square plus AB square. Now as the given triangle is is right angle triangle, so we have AC square is equal to AB square plus BC square. We are talking about this value AB square plus BC square. And what is the value of AB square plus BC square? It is AC square. So the final answer you will get it equal to 1. So on adjusting these terms, we are talking about these terms over here, the value of these all terms, it comes out to be 1. So if we cross multiply these terms, we will get the final answer, that area of triangle BCD plus area of triangle ABF, that is equal to area of triangle CAE. And this is what we have to prove, that the area of the triangle on the hypotenuse, that is equal to sum of the areas of the triangles on the other two sides. Next is given a right angled triangle ABC and the length of the side containing the right angle R, it is 6 centimeter and 8 centimeter. So we are saying the length of this side AB, it is given to be 6 centimeter, and length of this side BC is given to be 8 centimeter. This angle at B, it is 90 degree. A circle is inscribed in triangle ABC. Find the radius of the circle. So a circle is inscribed in this triangle. So we are saying let O be the center of this circle that is inscribed in it. So we are saying we have the points P, M and N where this circle touches the triangle ABC. And what we have is that this OM, it is perpendicular on AB, this ON is perpendicular on BC, and OP is perpendicular on CA. Now we are considering that R be the radius of this circle. So we have this length OM, OP and OR, all these lengths, these are equal to R. Now what we have is that AB square, that we are talking about this length, plus BC square, that is equal to AC square. So what we get from this is that this length of AC, that is square root of 8 square plus 6 square, and the value we will get it is 10 centimeter. This is 6 centimeter, 8 centimeter, and this value is 10 centimeters. Now if we talk about the area of the triangle BCO, we are talking about this triangle over here. We are saying ON is the perpendicular for this and BC is the base for this. Why we are saying so? Because if O, we are saying it is the center of the circle inscribed in it, it means that this OM, it is perpendicular over here, this OP is the perpendicular over here, and ON, it is the perpendicular over here. So area of this triangle we have, it is half into base into height. The area of this triangle we have, it is half, we are talking about this triangle over here, OCA, we are talking about this triangle, and the area of this triangle will be half AC into OP. And third, we are left with this triangle, and the area of this triangle is half AB into OM. Now if we add all these three values, we will get that the area of the triangle, that is equal to half 6 into 8. This side is 6, this side is 8. So we are talking about the area of the triangle ABC, that is equal to sum of the areas of all these triangles. So half we have taken common, so it is AB into OM plus BC into ON plus AC into OP. We are saying this is AC into OP is corresponding to this triangle. Then we have BC into ON. This is corresponding to the second, and this area is corresponding to the third value. Now what we have is the value of AB, we have it is 6, OM it is R, plus BC it is 8, ON it is R, plus AC we have calculated is 10, and OP it is R. So this gives us this 1 by 2 and 1 by 2 gets cancelled, and this total value, it comes out to be 24 R. So the value of R we will get it is 48 by 24, that is equal to 2 centimeters. So this answer we are getting is that the radius of this circle will be 2 centimeters. Now next we have is proof that the sum of the squares of the diagonals of a parallelogram is equal to the sum of the square of its sides. So to prove this result, we are talking about if we have a triangle ABC, we are talking about this triangle ABC, and AD, we are saying this is the median of this triangle. Then we have AB square plus AC square, that is equal to 2 times AD square plus BD square, and this is equal to 2 times AD square plus 1 by 2 times BC square. This result for this triangle we have already proved in our previous lectures and slides. Now we come to this question, and we are saying O is the point of intersection. This O, this is point of intersection of the diagonals PR. This is the diagonal PR, and this is the diagonal SQ of this parallelogram. Now we know that the diagonals of the parallelogram, they bisect each other. Both these lengths PO and OR, SO and OQ, these lengths, these are equal. So O is the midpoint of, we are saying it is O is the midpoint of PR. Now if we look at the triangle PQR, I'm talking about this triangle PQR over here. This is PQR. We are saying for this triangle, we have drawn this point O over here, and what we have is that this length OP and OR, these two lengths are equal. So this OQ, this is just the median for this triangle. So we can apply this formula over here, and what we will get is that PQ square plus QR square, that is equal to 2 times OQ square plus 1 by 2 times PR square. Similarly, if we consider this triangle PRS, in this triangle we are saying this SO, this is the median. So applying this result, we will get the values RS square, you will get this expression, plus SP square, that is equal to 2 times OS square plus 1 by 2 times PR square. Now if we add both these expressions, we will get it is PQ square plus QR square plus RS square plus SP square, that is equal to 2 times OQ square plus 2 times OS square plus PR square. Now if we look at this value, we are talking about OQ. What is this length OQ? This is 2, and this value we are saying it is half of SQ square plus 2 times, what is value of OS, we are saying that is equal to half of QS square. Now what this combined value comes out to be, this is equal to QS square. So we get the final result in the form that PQ square plus QR square plus RS square plus SP square, all these values we are talking about, these are equal to this value, we are left with this QS square, and the second value we are talking about, it is PR square, and this is what we have to prove, that SP square, that is equal to PR square plus QS square. Now the next question is, given a triangle ABC in which angle B is 90 degrees, we are talking about this angle is given to be 90 degree, and AB length, that is given to be, this length we are talking about, this is AB, it is given that it is equal to root 3 times BC. We have to prove that angle C is 60 degree. So first of all, we have done the construction, and we are saying let D be the midpoint of the hypotenuse AC, and we have joined B and D. So we are saying this BD is basically the median we have drawn. Now for the triangle ABC, what we have is AC square, that is equal to AB square plus BC square. Now value of AB, it is given that it is root 3 times BC square plus BC square. So what we get is, it is 3 times BC square plus BC square, that is equal to 4 times BC square. So we get AC is equal to 2 times BC. We are saying this AC length, this is 2 times BC length. Now we are saying D is the median. It means this length DC, that will be equal to the length BC. We are talking about these two lengths, these are equal to each other, because AC length, it is 2 times BC, and this length is half of AC. It means using this result we are getting that DC is equal to BC. Now we know that this result is mentioned over here, that the midpoint of the hypotenuse of a right triangle is equidistant from its vertices. We are saying the midpoint of the hypotenuse of a right triangle is equidistant from its vertices. So what we get is that BD is equal to CD. Now combining all these results, we are getting it is equal to BD. So if we look at this triangle over here, we are saying it is DBC. On this triangle we have BD is equal to DC is equal to BC. It means this triangle we are talking about, this is an equilateral triangle. And if it is an equilateral triangle, so this gives us angle C is equal to 60 degree. We get that angle C that is equal to 60 degree, and this is what we have to